Okay students, so in our previous class we had finished exercise 3.2 of matrices class 12 third chapter. So in this class we'll be starting with the next exercise 3.3. Okay, and here as I have told before as well, okay, in each exercise whatever questions we are solving on this board, okay, those all are important questions. So whatever questions are not solved on the board, okay, they are not pretty much important, but you can try those questions. Okay, those questions whatever I am not doing on the board, you can try those questions on the, you can try those questions, and any doubts in those you can just let us know by commenting in the comment section. So starting with the very new exercise 3.3, okay, we have taken the very first question as question number 4 and we'll start solving this. Alright, so the question here is, if a dash is equal to minus 2 3 1 2 and b is equal to minus 1 0 1 2, then find a plus 2b the whole dash. So what is the dash representing here? The dash is nothing but representing the transpose of a matrix. So first what we have to do, whatever is inside the bracket, okay, we'll do that first. So that is the sum of two matrices. After getting the sum of two matrices, we have to transpose that matrix. Okay, so that will be our final answer. Now here if you see A we already have as it is. So here we have A, but what is given here students? A dash is given. B is given here. So scalar multiplication, 2 multiplied with b, so sum we'll find out. So this is a, right? We have to find out a plus 2b. So how do we find out a? So solution will start from here. A can also be written as a dash the whole dash. How do we know this? Properties of transpose of a matrix. Okay, so a dash will write first. What is a dash? That is given here already. That is minus 2 3 1 and 2. So this is our a dash. Now dash this means transpose this. What is the meaning of transpose? Again, writing the rows as columns and vice versa, columns as rows. So this will become minus 2 3 and this will become 1 and 2. So this is the transpose of a dash. This will be equal to what now students? This will be equal to a. So we got a now, correct? 2b. So b, we already have b here. So scalar multiplication 2b, this can be written as 2 matrix b as it is. So that is minus 1 0 1 and 2. So this should be equal to what students? Matrix multiply this scalar 2, so it will become minus 2 0 2 and 4. So this is our 2b. We got a, here we'll write, which is equal to 2b. We got a and we got 2b, right? Now we have to add them both and take the transpose. So a plus 2b, we can write it like this. A plus 2b is equal to, so what is a? Minus 2 1 3 and 2. Minus 2 1 3 and 2. Plus what is 2b? 2b is written like this. Minus 2 0 2 4. 2 0 2 4. Add them both. So matrix addition, how do we operate matrix addition? Corresponding elements must be added up. Okay, minus 2 plus into minus is minus only, so minus 2 is nothing but minus 4. 1 plus 0 is 1, 3 plus 2 is 5 and 2 plus 4 is 6. What is this sum students? This sum is nothing but a plus 2b. Is this our answer? No, we have to take the transpose of that and that will be our final answer. So final answer, we'll write it down here. Okay, a plus 2b the whole transpose. So we'll just do the transpose now. Minus 4 1, minus 4 1, 5 and 6, 5 and 6. So this is our desired answer. So this is what we had to find out. Means a plus 2b we found out here, right? Transpose of this we have written here. And this is our final answer. Alright, moving on to the next question. Exercise 3.3, question number 6. If a is equal to sine alpha cos alpha minus cos alpha sine alpha, then verify that a dash into a is equal to I. What is this I, students? Identity matrix. Means what? The principal diagonal elements are plus 1 and the other elements are 0. A dash transpose of A is as it is. So we'll directly write this. A dash dot A, write the transpose of this matrix. So transpose will become sine alpha cos alpha minus cos alpha sin alpha. This is A dash dot. What is A, students? A is this only as it is. So that is sin alpha cos alpha minus cos alpha and sin alpha. So when you multiply these both matrices, what should we be getting? We must be getting an identity matrix. Okay, so let's just check that out. So matrix multiplication, how is it done? Rows into column, rows into column. Okay, so first row into first column. Sin alpha into sin alpha is nothing but sin square alpha. Minus cos alpha into minus cos alpha is plus cos square alpha. First row into first column, we got the first element here. So before that, can we do the matrix multiplication here? Just check that out. The order of this matrix is 2 cross 2. Order of this matrix is also 2 cross 2. These both are matching, right? The number of columns in this matrix is equal to the number of rows in this matrix, which means what? We can matrix multiply this. What are the other two numbers representing here? The other two numbers are representing the order of the product. Understanding? Okay. So first row into first column, we got the first element. Next, first row into second column. Sin alpha into cos alpha. Write it as it is. Sin alpha into cos alpha. Minus cos alpha into sin alpha. Minus cos alpha into sin alpha. Close the bracket. Next, second row into first column. Cos alpha into sin alpha. Plus, okay, cos alpha into sin alpha, plus sin alpha into minus cos alpha is minus sin alpha into cos alpha. Second row into second column, cos square alpha plus sin square alpha. Okay, so this is what? This is our A dash into A. This is our matrix product. Is this equal to I now? So here what will happen? Plus sin alpha plus cos alpha multiplication minus sin alpha into cos alpha. These both will get cancelled. Here we'll be writing 0. Plus and minus. Same thing here. These both will get cancelled. Here we'll be writing 0. What is sin square alpha plus cos square alpha? What is this? A trigonometric identity. Correct? So this is a trigonometric identity. This is equal to what? This is equal to 1 as well as this is equal to 1. Same thing. Sin square alpha plus cos square alpha. Here we have written cos square alpha plus sin square alpha. So therefore, A dash into A, this is equal to 1, 0, 0, 1, which is equal to I 2 cross 2. Means it is an identity matrix, and what is the order of I? 2 cross 2. So that is what? And we have hence proved. Okay, so these both are the important questions of exercise 3.3. Moving on to the next question. I hope you have understood this. Okay students, moving on to the next question. Next set of important questions under exercise 3.3 only. Okay, the next question which we have taken here on this board is question number 7, second sub question, and here the question is show that the matrix is a skew symmetric matrix. So how do we know the matrix is a skew symmetric matrix? If suppose A is the given matrix, alright, if A dash is equal to minus A, then we can call that matrix as what? A skew symmetric matrix, correct? Now here we'll see A is given, okay, A dash we'll find out. So what would be A dash here? Writing rows as columns and columns as rows. So A dash would be 0, 1, minus 1, minus 1, 0, 1, and 1, minus 1, 0. What is this students? This is our A dash. Now if this A dash is equal to minus of A, so here what we'll do, this is A dash, we'll keep it as it is. Now multiply this matrix with minus 1, scalar multiplication. Okay, minus 1 or minus also you can take directly. Okay, so write 0, minus 1, 1, same matrix I'm writing, 1, 0, minus 1 and minus 1, 1 and 0. Scalar multiply this minus 1 inside the matrix, what are you going to get? So minus 1 into 0 is 0 only, this is becoming plus, minus, minus 1, 0, 1, 1, minus 1 and 0. Check whether this is A. Is this A? 0, 1, minus 1, minus 1, 0, 1, 1, minus 1, 0. So therefore what did we see here? A dash is equal to minus of A. Therefore what can we tell? Okay, we can tell that, or we have shown that this matrix, the given matrix, is a skew symmetric matrix. Okay, so this is how you have to do to get the marks. But just by looking at the matrix, how do you tell it is a skew symmetric matrix? So just eliminate or ignore this principal diagonal. The other elements must be mirror images of each other. Alright, the other elements must be mirror images of each other with the opposite sign. So if there is plus here, there must be minus, plus here, there must be minus, and if there is plus here, there must be minus as well. So then we can tell that the given matrix is a skew symmetric matrix. Okay, moving on to the next one. Express the following matrices in the sum as the sum of symmetric and skew symmetric matrix. How do you express the sum as symmetric matrix? Let P be the symmetric matrix 1 by 2 A plus A dash. For skew symmetric matrix, how do we express? Let us take Q here, 1 by 2 A minus A dash. Okay, so this is how you have to express a matrix. Okay, this is the given matrix, right? Let us take this matrix as A. Okay, now you have to express the given matrix in the form of symmetric by using this and skew symmetric matrix. So we'll start with the solution here. So while writing the solution, we'll write consider P as symmetric matrix. Consider P as a symmetric matrix. Now use that formula. P is equal to 1 by 2 of A as it is, students, correct? See here, A as it is. So here we'll write 3, 5, 1 minus 1. 3, 5, 1 minus 1 plus A dash transpose of A. So this will become 3, 5, 1 minus 1. Close the bracket. Add these both matrices. So here what will happen? P is equal to 1 by 2 of, open the bracket, 3 plus 3, 6, 5 plus 1, 6, 1 plus 5, 6, minus 1, minus 2. Close the bracket. What do we have outside? Outside we have 1 by 2, right? Scalar multiply this with the matrix here. What will be getting? We will be getting P equals, so 6 by 2 is nothing but how much? 3. 6 by 2 is again 3. 6 by 2 is again 3. Minus 2 by 2, that will become minus 1. Is this a symmetric matrix? Yes or no? How do we know that? Ignore the principal diagonal. Other elements must be mirror images with the same sign. Are they both mirror images 3 and 3? Yes. Same sign is also there? Yes. Which means what, students? They are symmetric matrix. Another way, A dash is equal to minus A, right? Then we call it as what? Skew symmetric matrix. If suppose A dash is equal to A, then we call it as what? Symmetric matrix. Now find out what is P dash. So P dash here will write, P dash will be written as 3, 3 and 3 minus 1. What can we see here? P dash is equal to P. Therefore it is a symmetric matrix. Okay. So coming to the skew symmetric matrix. So here consider P as a symmetric matrix we have written, right? Here we'll consider Q as a symmetric matrix. Okay. So consider Q as skew symmetric matrix. Consider Q as skew symmetric matrix. So A minus A dash, Q equals 1 by 2. What is A? A is nothing but this one only. Okay, 3, 1, 5. 3, 5, 1 minus 1. Minus A dash, transpose this. This will become 3, 5, 1 minus 1. What is the operation in between two matrices? Subtraction. How do we subtract two matrices? Corresponding elements must be subtracted with each other. Then what should we do? Scalar multiply this scalar with the matrix whatever we get here. Then it will be what? We should check whether it is skew symmetric or not. So continuing, 3 minus 3 is how much, students? Q is equal to 1 by 2. Open the bracket. 3 minus 3 is 0. 5 minus 1, 4. 1 minus 5. 1 minus 5 is minus 4. Correct? minus 1 minus of minus 1, 0. Minus of minus will become plus, minus 1 plus 1 is 0, which is equal to, scalar multiply this 1 by 2 inside, so 0 by 2 is 0 only, correct? 4 by 2 is 2, minus 4 by 2 is minus 2, half into 0 is again 0. Is this a skew symmetric matrix, yes or no? How do we know? Ignore the principal diagonal, other elements must be mirror images but with opposite signs. So here you can see plus 2 and here we have minus 2, which means what? The other elements are mirror images of each other but with the opposite sign, which means what? It is a skew symmetric matrix. Mathematically, how can we see that? If q dash, now let us take q dash, this is q, right? This is q. Find out what is q dash. Q dash will be equal to 0, 2, minus 2, 0. This is q dash. Is q dash equal to minus of q? Multiply this minus sign inside. It will become minus 2 plus 2. So here what are we getting, students? Here we are getting q dash is equal to minus of q. Therefore what can we tell? The given matrix is a, or whatever matrix we got here, q, is a skew symmetric matrix. Understanding? So this was a pretty much lengthier sum. The important points, okay, to be remembered here are, okay, I'll just highlight them, students. Make a note of that. So see, this is very important. This is also very important. And apart from this, yeah, this is important as well as this is important. Okay. Going on to the next question. Exercise 3.3, 10th, third sub question. Same thing, same heading. Express the following matrices as sum of symmetric and skew symmetric matrix. So this was what? 2 cross 2 matrix. Here we have 3 cross 3 matrix. So symmetric and skew symmetric, right? So on this side we'll be doing symmetric. So again, what should we consider? Let us consider P as a symmetric matrix. Okay. So P can be written as what? 1 by 2 of A plus A dash. A is written here already, so P equals 1 by 2 of, open the bracket, 3, 3 minus 1, minus 2, minus 2, 1, minus 4, 5, minus 4, minus 5, 2. This is what, students? The original matrix A. Now we'll write A dash plus. A dash is nothing but what? A transpose means writing the rows as columns and vice versa. So this will become 3, 3, minus 1, minus 2, minus 2, 1, minus 4, minus 5, 2. This is our A dash. Add these both matrices. So how do we add matrices, students? Adding the corresponding elements of two matrices. Just corresponding elements you have to add. So P will be equal to 1 by 2. Okay, open the matrix. 3 plus 3, 6. 3 plus of minus 2 is 1. Minus 1 plus minus 4 is minus 5. Minus 2 plus 3 is 1. Minus 2 plus minus 2 is minus 4. 1 plus of minus 5 is minus 4 again. Minus 4 plus of minus 1 is minus 5. Minus 5 plus 1 is minus 4. And 2 plus 2 is 4 again. Is this a symmetric matrix? Ignore the principal diagonal, which means leave this line. Okay, leave this diagonal. Principal diagonal is nothing but AII. Other elements are mirror images of each other? Yes, they are mirror images of each other. Just by looking we can tell, right? So therefore, we'll just scalar multiply this inside. What we'll be getting? P equals 6 by 2 is 3, 1 by 2 is 1 by 2 only. Minus 5 by 2 is minus 2.5 will write. Okay, or you can also write minus 5 by 2. Both are same. So that is in the fractional form. This is in the decimal form. So this again will become 1 by 2. This will become minus 4, means it will become minus 2. This will become minus 2 again. This is becoming minus 2.5, minus 2 and 2. This is P. What is P dash, students? P dash equals transpose of this. So that is nothing but 3, 1 by 2, minus 2.5, 1 by 2, minus 2, minus 2, minus 2.5, minus 2, 2. What can we see here? Is P equal to P dash? Yes. Here we can see P is equal to P dash. Therefore, P is a symmetric matrix. Okay, so here we'll draw a line. What we have proven? The given matrix we have expressed it in the form of symmetric matrix by using this formula. Next, after symmetric, what we have? Skew symmetric matrix. Skew symmetric. So let us assume that Q as a skew symmetric matrix. If Q is a skew symmetric matrix, then Q can be expressed as what? 1 by 2 of A minus A dash. What is A, students? That is given here already, correct? Q equals 1 by 2 of 3, 3 minus 1, minus 2, minus 2, 1, minus 4, minus 5, 2, minus A dash 3, 3, minus 1, minus 2, minus 2, 1, minus 4, minus 5, 2. This is our A dash. Now subtract these both matrices, what will be getting? Q equals 1 by 2 of, subtract students, 3 minus 3, 0, 3 minus of minus 2, 5, 1 minus of minus 4, so it will become plus 4 minus 1 is 3, minus 2 minus of 3 minus 5, minus 2 minus of minus 2, that will become plus 2 minus 2 is 0, 1 minus of minus 5, so it will become plus 5, so 1 plus 5 is 6, minus 4 minus of minus 1, that will become plus 1, minus 1 plus 1 is minus 3, minus 5 minus of 1, so it will become minus 6, 2 minus 2 is again 0. Just by looking at this, is this skew symmetric? Ignore this principal diagonal, other elements must be mirror images but with opposite signs. Is it so? Plus 5 minus 5, plus 3 minus 3, plus 6 minus 6, therefore just by looking we can tell it is a skew symmetric matrix. But we have to also prove that, right? So scalar multiply this 1 by 2 with all the elements of this matrices. Q will be equal to, so this will become 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 3, minus 3 by 2, minus 3 and 0. Check again, leave this diagonal, plus 5 by 2 minus 5 by 2, plus 3 by 2 minus 3 by 2, plus 3 minus 3. So this is our what, students? This is our Q. We'll find out Q dash now. So Q dash will be equal to transpose of the above matrix. So that will be 0, 5 by 2, 3 by 2, minus 5 by 2, 0, 3, minus 3 by 2, minus 3, 0. So now what can we tell, students? Can we tell that Q dash, which is this one, is equal to minus of Q? Yes or no? So if you multiply minus to this, whatever Q matrix we got, we'll be getting Q dash matrix. It's very evident. So therefore what can we write here? Therefore Q is a skew symmetric matrix. So again, how did we get the skew symmetric matrix? By using this formula. Symmetric using this formula. Very simple, students. Symmetric use plus, skew symmetric use minus. What is the condition to prove that it's symmetric? Q dash, okay, sorry. It is P dash equals P, symmetric matrix, skew symmetric matrix, Q dash equals minus Q. Okay. So this is the important problems of exercise 3.3. There is only one more question left out, which is an MCQ. Okay, we'll be doing it as the next question. Okay, students, moving on to the next problem. The very last problem of exercise 3.3. So this is an MCQ question which we have here. Okay, we'll solve this problem. Read the question first. If A and B are symmetric matrices of same order, okay, symmetric matrices of same order, then AB minus BA is what? Okay, so you can assume a matrix for A, matrix for B. Okay, do this matrix multiplication and the difference and finally find out. Okay, that will take some time. So what we have to do here is we'll be using matrix algebra again. So what is matrix algebra? For example, see there are few terms. For example, A minus B, the whole dash can be written as what? A dash minus B dash. Similarly, AB matrix multiplication of whole dash, which means equal to what, students? B dash into A dash. So what are these both? Points to remember. Okay, now let's start solving that question. AB minus B, they are telling A and B are symmetric matrices of same order, right? So A and B are symmetric matrices means what? A dash is equal to A and B dash is equal to B. Why are we writing like this? Because A and B are symmetric matrices. That is the reason we are writing A dash equals A and B dash equals B. Now we have to find out what is AB minus BA, right? So what is the difference of AB minus BA if A and B are symmetric matrices? So let us write that down as it is. AB minus BA, let us put the whole dash for this. So this can be written as what, students? According to this, it can be written as AB the whole dash minus BA the whole dash, correct? Now, AB the whole dash can be written as B dash into A dash, right? Which is equal to B dash into A dash minus A dash into B dash. And what is B dash? Equals B, and what is A dash? Equals A. So this is nothing but B A minus A B, correct? Because they are symmetric matrices. The same thing only we got, right? So this again can be written as they are of the same order. So here we'll write AB minus BA again. Okay, sorry, not AB minus BA, so this is wrong. Okay, what we have to do here is we have to take this minus sign common. What will be getting? So on the left hand side we'll be having AB minus BA the whole dash, which is equal to, take the minus sign outside from here. If you take out that minus sign, you will be getting AB minus BA. This is very similar to what, students? Q dash is equal to minus Q. This type of matrix is called as what? A skew symmetric matrix. So therefore, if A and B are symmetric matrices, see here A dash equals A, B dash equals B, of same order than AB minus BA. So we have taken that only right on the left hand side, AB minus BA the whole dash, applying these both properties. So this will be equal to what? Skew symmetric matrix. Why? Because AB minus BA the whole dash is equal to minus of AB minus BA, which is very similar to Q dash is equal to minus of Q. Therefore, skew symmetric matrix is the right answer. So this is the last question of exercise 3.3. In our next class, we'll be starting with exercise 3.4. Thank you, students.